Today I'm going to be running the preparation of an organometallic bismuth compound called triphenylbismuth, and we are going to make this by the transmetallation between bismuth trichloride and the Grignard reagent phenylmagnesium bromide. Starting off, a crystal of iodine was added to the flask, followed by 1.7 grams of granular magnesium. I then gently heated the flask over a flame, which sublimated the iodine, activating the magnesium. I made this prep through a hybrid of the triphenyl antimony synth on Orexin, and from this paper on making substituted triphenylbismuth compounds. I prefer using magnesium granules over powdered magnesium, as it slows down the reaction substantially and greatly reduces the risk of having a runaway from overloading the flask with organohalide, as you can see happening in this reaction. The flask was then charged with 50 ml of ether through the addition funnel. Next, I dissolved 11 grams of bromobenzene in 50 ml of ether and then charged that into the addition funnel. To begin the formation of the Grignard reagent, I first added a few mils of the ethereal bromobenzene solution, and I then allowed it to stir for a few minutes before further addition. The mixture darkened as the iodine that had sublimated onto the walls of the flask was carried into solution. The iodine coloration slowly faded as it reacted with the magnesium surface, and at this point, the dropwise addition of the ethereal bromobenzene was started. Once the addition had been completed, the reaction was stirred for an additional 30 minutes. Meanwhile, 7 grams of the bismuth trichloride was weighed out and dissolved into 50 ml of ether. The chunks were surprisingly solid and slow to dissolve, obviously, so I ended up having to remove them from the ether and pulverize them to permit dissolution. With vigorous stirring, the bismuth trichloride solution was rapidly added to the phenylmagnesium bromide. The mixture was then refluxed for 1 hour and then allowed to cool. Next, the mixture was quenched into 200 ml of saturated sodium bicarbonate solution. Acid can't be used here to dissolve the precipitated salts, as the triphenylbismuth is sensitive to acids and will decompose. As such, filtration must be carried out to remove the precipitated salts, and I then washed the residue with 20 ml of ether, and there was some crystalline solid that formed into the filtering flask, and after adding a bit of ether to that and shaking, the solid redissolved. The filtered liquid was then transferred into a sep funnel, and the ether layer was then separated off, and the aqueous layer was then extracted with 20 ml of ether. And finally, the two ether layers were pooled. Next, the ether layer was then washed twice with 100 ml of saturated sodium chloride, and then dried over anhydrous magnesium sulfate. I then filtered the mixture into a round bottom flask, and then set up for a simple distillation. I removed the ether on a hot water bath, and after the ether stopped coming over into the receiving flask, heating was turned off and the flask was allowed to cool. What remained in the flask was some liquid with a little bit of precipitate, and on pouring this liquid into a crystallizing dish, it immediately started forming crystals and solidified. The crude product recovered ended up weighing 6.8 grams, and the next step was a recrystallization from hexanes, and I ended up using about 20 milliliters of hexanes in the recryst. Some solid remained in solution, so I had to run a hot filtration. After cooling to room temperature, these really nice, lovely crystals formed, and I then put the flask in the freezer to allow it to fully crystallize out. The hexanes was decanted off, and I washed the crystals with a little bit of cold hexane. I ended up with 4.5 grams of product, representing a 46% yield. I ran a TLC against some of the crude product and this recrystallized product with a 9:1 hexanes to ethyl acetate solvent system. I circled the spots and you can see that they're very clean and tight, surprisingly for both the crude and the recrystallized samples. The next purity test I ran was the melting point, and it gave me a value of 78 to 78.3 degrees Celsius, quite a tight range. And the theoretical is surprisingly quite a large range of 76 to 81 degrees Celsius. And since I'm comfortably within that range, I am quite confident I have the desired product, triphenylbismuth. As the melting point and the TLC that I ran were both very clean, there's likely no substantial impurity. However, pure triphenylbismuth should be white to a light buff color, and mine has a quite apparent yellow coloration, so there likely is some minor impurity. And it's quite possible that this yellow impurity originated during the formation of the Grignard reagent, and I've actually noticed this yellow impurity in some other Grignard reactions that I've done, and it followed all the way through up until I distilled over the product. And since we're not doing a distillation of the product here, the yellow coloration was able to remain in the final triphenylbismuth. Perhaps recrystallizations from different solvents, or maybe sublimation of the triphenylbismuth would be successful in removing this yellow color.